Hey guys, it's Mo. Today I'm gonna walk you through the little water lab investigation that you guys got. We got a lot of materials here. This is pretty much all you need: paperclip, penny, dropper, cup of water, microscope slides. So if you got the materials, you are more than welcome to just totally ignore this video and like move on and do all of them. But if you maybe are confused about parts, or if you want to use my data, if you're not getting it, feel free to watch this video and do it there, okay? So I'm going to walk through all of the pieces and kind of talk you through them. There's going to be a lot of stops and restarts. So just bear with me. My videography is not super great. Okay. Okay, so under the adhesion section, the first thing asks you to take two microscope slides. They look like this. Okay. And place them together. Okay. So as you can see, the one that's sitting in this hand, it's just kind of hanging out there. I'm putting them together. I'm pulling them apart. Okay. Now what we're going to do is we're going to take a drop of water and place on one of the microscope slides. Okay, so now we've got this one little drop here. You can kind of see it on there. We're gonna tap them together and we're gonna see what happens. Check it out, they both are stuck together now. Okay, so now I'm on cohesion, and all I need for this is a penny and my dropper. Okay, so it asks you to predict. So before you get started, predict. And then what you're going to do is you're going to put drops of water on the penny. "20, 21." You can see it bubbling up. 22, 23, 24, 25, 26, 27. All right, 27, and then it popped off of the penny. Alright, so same experiment. I have cleaned off my penny. This time what I'm going to do is I'm going to take a little bit of soap and put on the penny first. Rub that around really good. Okay, so now we've got our penny soaked up, and we're going to see if that changes anything, if we're going to be able to get more or are we going to be able to get less. 1, 2, 3, 4, 5, 5, and we've spilled over here on this side. Okay, so we have way less. Your job is to analyze why dish detergent would actually cut the water and not allow it to hang out together. Okay, the next section of cohesion asks you to fill a petri dish with water and then place your finger on the surface of that water. Okay, and so I did that, and then as I pull my finger off, you can see the water kind of tries to cling to it, and it's kind of moving upward, okay, against gravity. Okay, so cohesion obviously is water sticking to water. So why do we think that that would happen? That first off, it's sticking to my finger, and then as we move up, the water likes to kind of hold to your finger. Okay, so the next section is called capillarity, okay, and what it asks you to do is stick a piece of filter paper into the water. Okay, so I've actually let this sit here just a little bit of time, but you can see my water line is here, okay, and then you can see that the water is actually climbing up that higher than the actual water itself. Okay, so you can kind of see where I'm like moving it, and you can see where the actual water line is, and then versus where the water is actually at onto the filter. Okay, so the next section we are on is surface tension. All you really need for this is a paper clip and a cup of water. Okay, so in my cup of water, I'm going to take the paper clip. We know these things about metal, they typically drop straight down. So I'm going to take my cup of water and put my paper clip in vertically and drop it. And yeah, it did. It sank all the way to the bottom. Okay, we are resetting. So we have our paper clip. This time we are going to try and hold it horizontally, okay, and lower it into the water instead of vertically. So we go nice and slow, and check that out. The paper clip floats. I do not want to say floats. It sits gingerly on top of the water, on top of that surface tension. It's still metal, so if I were to break that surface tension, boop, it'll go straight down to the bottom. Hey guys, so that is it for the water lab. So if you have any questions about any of those things, I do want to say that those are all properties of water to an extent that they contribute to the way that water acts and kind of behaves. Uh, but the ones that, you know, the one thing about water that is super cool that everybody needs to know is the reason that it has all of these awesome properties and can do all of these awesome things is because it's polar. Okay, so don't you forget about that. Make sure that you complete that lab and submit it. If you have any questions, please let me know. I'm here for you. Okay, so best of luck. Let me know if you have any problems. Bye.